Hello everybody, and welcome to the first in our series of 3 webinars which are focused on RaySearch's next generation OIS RayCare. My name's Vanessa Ashby and I'm the Business Development Manager here at RaySearch, and I will be moderating these sessions. I just want to start by reminding you all that if you haven't already registered for the next 2 sessions, the first one on the 15th of February and the next on the 22nd, then remember to do so. All of these webinars are hosted at 2 p.m. Central European time, and the recordings will be available after for all the registered participants. Back to today, we are going to hear from Leuven from Leuven, a medical physicist who is basically going to share their RayCare experience. A little bit of housekeeping before I hand over. Questions can be asked using the Q&A function during the session, and we'll address as many as possible at the end of the presentation. So take it away, Leuven.
Yeah, hello. Thank you for your introduction, and it seems we're starting right on time, so that's also really good. I'm indeed Leuven Goedgebeur, medical physicist from UZ Leuven, on the particle side and on the photon side as well. And I'd like to show you our safety and efficiency in our RayCare IBA ProteusOne facility, where I'd like to show you our particle workflow. Yeah, here is an overview of this presentation. So I'd like to show you our particle setup in UZ Leuven, really show us our RayCare RayStation journey so far, and really go through really specific efficiency and safety focus points using a whole ventricular irradiation use case, where I'd like to show you our RayCare workflow, see what happens when we plan a sequential beam set, and also see what happens when our proton machine breaks down, so when we deliver a backup photon treatment. I'd like to finish off with the overview of our focus points in our RaySearch IBA setup, and I'd like to look back and look forwards to the future. Here are my disclosures. And I'd say, yeah, welcome to our particle setup. So particle being the name of our proton therapy division located within UZ Leuven. So we're collaborating within a network of university hospitals here within Belgium. At our facility, we have our IBA ProteusOne, consisting of a compact gantry. So rather than a full 360-degree gantry, we have the 220-degree gantry. And in order to treat both sides of the patient, we need to rotate our table 180 degrees. We have the full RaySearch software spectrum, meaning RayStation RayCare, and that's interacting nicely with our IBA software, so IBA imaging and delivery software named Adapt Insight and Adapt Deliver. We also have our Siemens in-room CT, and we've been clinically treating patients for a bit more than 3 years now, so actually 4 years in July this year, so yay. And at the time, we were one of the first with a specific RaySearch IBA setup. And since being clinical, we've, of course, incorporated multiple improvements into our workflow, which I'd like to show you all in this session, basically. Within our patient population, we treat really a majority of pediatric patients. So 60% of our 220 patients that we've already treated were less than 18 years old. And I would also say 15% of our patients are treated under anesthesia. So that's daily anesthesia, that is. And that's generally for children less than 6 years old. Also quite notably that we treat a lot of craniospinal irradiations, so our CSI, so that's about 30%. I would say that's kind of our specialty, at least that's how it feels like. And apart from CSI, we also do general intracranial irradiations, head and neck cases, sporadically. We also do esophagus patients within the PROTECT trial, and apart from that, also abdominal and paraspinal indications. And yeah, we've basically been using RayCare, RayStation for more than 3 years now, nearly 4 years. And ever since we started our proton treatments back in 2020. And at the time, we really were the world first users of RayCare in combination with our IBA ProteusOne system. So that was both frightening and exciting as well back in the day. And something I want to highlight is that we basically had our yearly RayCare upgrades to a newer version. And nice to note that every RayCare version is linked with a specific RayStation version. So RayCare and RayStation versions go basically hand in hand. We are currently on RayCare version 5A with RayStation 11A, and we are upgrading end of this month to RayCare 6A and RayStation 12A. So yeah, that's gonna happen. So yeah, we've seen our variety of icons through the years. I couldn't find all of the icons basically. So I already want to note that upgrading does result in really high workloads on the MPE and quality manager for us. So the workload wise to perform all of those validation each time. But once we've upgraded, we have both the newest RayCare and RayStation package. So yeah, personally, when we upgrade end of this month, I'm really looking forward to having that possibility to adopt our RayCare workflows in-house, because in the previous versions that we had, that was only possible to be done centrally by RaySearch, and soon we will then be able to do that ourselves as well. On the RayStation side, I'm looking forward to having a lead evaluation clinically available for a proton plan. So yeah, that's definitely also something our radoncs look forward to, I would say. So yeah, that's going to happen soon for us. And here you see our RayCare workflow going all the way from proton round all the way to treatment start and treatment finish. And I would say in quite a few of these steps, we found little tricks which work well for us to incorporate so either safety or efficiency or both. And I'd like to go through these steps with you with a whole ventricular irradiation patient. So first time round, a patient gets introduced to us. That's during proton round. And here we are presented with a 12-year-old patient who requires whole ventricular irradiation, or WVI, with a prescription of 24 gray to the WVI volume and another 30.6 gray to the boost volume in a sequential scheme totaling to 54.6 gray. So quite luckily in Belgium, pediatric WVI is a standard indication for proton therapy. So therefore, this patient is basically automatically selected and accepted for treatment in our particle treatment. So our patient gets booked a slot on the CT simulation, and there our lovely team of RTTs welcome our patients. So that's nice. And our patient is simulated with the BOSS tabletop insert, a MoldCare patient-specific pillow, and a QFix mask. And this information is, of course, then entered into the setup instructions by our RTTs who follow the simulation component within the RayCare workflow for this patient. So yeah. Something I already want to add at this stage, quite important, is that the BOSS tabletop insert is in a fixed position on top of our CT simulation couch. This detail will be important later on for a calculation which will pop up later on in our workflow. So after simulation, it's time for contouring, and there it's time for our radonc to shine. So here you see the contouring of our radonc. You see the CTV. Let me get that video started. You see the CTV of the WVI in green, and as always, that's nicely surrounding that brainstem. And for the purpose of making this use case a bit more interesting and challenging, our radoncs let us know that they require additional MRI imaging. So therefore, the CTV boost volume is still in draft. And anecdotally, I would say this lateness of the boost happens actually quite often in our clinic, especially for CSI cases. So I would say the fictional complication that you see here is very much based on common occurrence within our clinic. Something you can also note already is that in the name giving of the CTV ROI, the doctor also put already CTV draft, basically. Another thing our doctor does to ensure communication and safety keeping of this is when our radonc is finishing off the RayCare task linked to the contouring. It's of course important that this sort of information is also passed on to the planner. And this is done by adding a comment in the task. Plus, what you've seen before is that the CTV boost name ROI also contains the word draft as an extra safety step by R&D. So that's contouring done for now, I would say. So we can move on to the planning phase. And good news, we can already get started with our planning of that first sequence of our beam set on the WVI volume. And good news, we've already made a robustly optimized 3mm 3% 4-beam PP plan on that CTV WVI volume. And yeah, as a planner, we're at this stage, we're ready to do some tidying up steps or plan checks before we pass this plan on to our second physicist, for example. First of our tidying up steps, and that we get the video started, is that we then you need to make sure to have only one setup beam. So RayStation makes 3 setup beams by default, and the IBA system only accepts a plan with a single setup beam, so we always need to manually delete 2 setup beams. Secondly, we also need to order our beams to the ideal order, so the most efficient order on our machine. And also to make our RTT life on the machine more easy, we also rename our beams to a sensible beam name. So my colleague Antoine made a really lovely script, which you see running here. And yeah, basically where we can name our beams automatically. When we load the plan and it's been on our machines, having that gantry, caps position, range shifter presence already in the beam name makes the delivery more intuitive for our RTTs. So yeah, we definitely received good feedback on that from our RTT team. So that makes me happy. Furthermore, within our plan tidying up steps, is that we create beam-specific low-dose ROIs, so representing the beam part for each beam. So let me get that video started. So you see those beam-specific ROIs basically there. And we also exclude unnecessary ROIs for so unnecessary optimization or planning structures from export. Keeping these unnecessary RT structures to a minimum helps us diminish plan transfer times from RayCare to RayStation, because that happens for every section. So that's keeping that transfer time to a minimum. So for me, it's a form of good housekeeping to do that, in my opinion. So it's basically just tick boxing the exclude from export button. So, and then maybe back on the beam specific ROIs, it's really good to have them there. So to make those and to have them available on our machine. Since on our PT machine, there's no such thing as a light field to be able to view the beam entry paths. So contrary to most Photon Linux, of course. And whereas having the beam entry path projection possible on the CBCT is just a really handy feature to make a quick online assessment of skin swelling or shrinkage, for example, since any anatomical changes are only relevant if they're in the beam entry path, basically. So subsequently, the RadOnc and MPE on call, who may not be familiar with the plan, can make a straightforward decision to continue treatment or order an in-room CT, for example, to perform further assessments. So that's done in this step. And as a last step in the planning phase, we fill in our sanity check questionnaire, as I like to call it. So it's basically a questionnaire making sure we've done all of the required tidying up steps in order to have a safe and deliverable plan. And this questionnaire, the same questionnaire, will come back further down the workflow for further MPE checks as well. So that concludes our planning phase of that first beam set, and we can move on to the MPE and MD checks phase, basically. So yeah, that's MPE and RadOnc plan checking component in our workflow. Exists out of a sequence of checking and approval steps. So after treatment planning, we have first physics review, followed by the plan check by our RadOnc. And if in treatment course, we perform our patient-specific QA, and then we follow up with the final physics approval and approval of the treatment course and setup instructions. So the first RayCare step in this component is the first physics check, where we check if the plan is safe and deliverable, of course. So there we have the following. Yes. Yeah. So to speed up the step, we found it really handy to have a plan overview using, again, a RayStation script. And let me show you how that's run. So we just load that script, and what it does, it basically prompts a pop-up where we can check some general plan parameters all in one screen. So we see the amount of beams, the min and max energy of each beam, minimum AU, dose grid settings, dose grid size, robustness parameters for evaluation, setup beam information, approval status, SLC plan CT information. So a whole bunch of information just in one pop-up. And the advantage of using the script is that we can basically check off half of our questionnaire, which is this one overview pop-up. So that saves us not having to toggle between all of the RayStation tabs too often. So that does save us some time, but for the other half of the RayCare checklist, because we have 30 questions in there, we still manually look at some parameters. For example, the visual dose evaluation. We have a look at the beam entry paths and any possible interference with the positioning devices, possibly collisions. And yeah, of course, the prescription of the plan needs to match the RayCare MD approved prescription and such things. So we have basically the best of both worlds, in my feeling. We use our script for some efficiency, and we do still look truly to into our plan. So our plan is happily reviewed by our medical physicist. So that's the first MPE check is done. And it's time for our RADONC to review the plan. And they are happy with our dosage at the moment. And they just approve the beam set. So I'm sure we all familiar with the approved beam set function within the RayStation. So after that, it's back to the medical physicist or planner, where we are prompted to specify the plan to use in treatment course. So basically, this task allows us to schedule the beam set into the RayCare treatment slots. And I have the plan already available for QA on RayTreat physics mode as well. So here we go to RayStation. And when performing this specified plan to use in treatment course tab, we are prompted with following pop-up. And there we can check our tolerance table again. So for this general, this WVI case, it's again our general brain tolerance table. There's also that checkbox if QA is required. So we want to perform patient-specific QA, so we keep that checkbox ticked. And we are also given the option to set our delivery tabletop position. And that's also an option that we want to enter, since this will bring us efficiency to our first treatment delivery fraction later on. And in order to efficiently calculate this, we have, again, a script to calculate this. So we start off with creating a top pin point. So that's basically a landmark position cranially in the tabletop insert. You see that there. And since this position is always the same during the CT sim phase, because I mentioned it before, we fixate our table inserts in a specific way on top of our CT couch. And we then project the vector from this top pin point, landmark point, to our localization point, or ISO, or and we perform a CT sim to IB coordinate calculation conversion, and we're able to get an expected XYZ in IBA coordinates. I do say expected, since on our table we are prone to some table sag, so especially at Z coordinates, they still need small adjustments. We then manually enter these calculated XYZ values as part of the use plan treatment course approval in RayStation. And these will then be passed on to RayCare RayTreat and to our IBA software, of course. So that's the whole chain following there. And once we've pushed that button and we've set the beam set to use planning treatment course, what it also does is it basically the first set of RayCare treatment slots are populated with this beam set. And at this stage, we can already deliver our plan in physics mode, in RayCare physics mode, to do our QA. And that's something that we do, of course. This is basically our QA step in our workflow. We prepare the QA plan in the RayStation, where we calculate the plan at 0-degree couch and gantry angles, calculate this in a phantom, and export the plans the planes at 2 centimeter deep, which is a depth where we will perform our measurement sets, and we export that to our IBA ProteusOne software. Here, if our plan is set to use in treatment course, we can deliver the plan already in RayCare physics mode, so not yet clinically. And here you see our screen in the treatment control room, where we have our RayCare treatment console. So basically where we have our normal patient treatment slots, and I will switch to QA mode and initiate that mode. So here you see me doing that. And then we normally have our patient treatment slots there, and we are prompted with all of our patients that need QA. So this time it's only our WVI case that needs QA. So we select the plan and open the QA session. So you see it's transferring that data. Then transferring the data to our IBA machine, and see the transfer data session turned green, basically. So that means all of the data has been sent from the RayCare treatment sites to IBA. I would say also the bending, yeah, you see that transferring the plan data to our IBA machine goes quite smooth, but depending on the plan complexity, this can take a bit longer. But for this 4-beam plan, you can see, yeah, it kind of goes relatively fast, in my opinion. We deliver all of our beams at gantry 0 onto the matrix PT and measure at 2 deep and perform our gamma analysis. And I would say, let's say for this purpose of this exercise, all our gamma results are satisfying for all of our beams. So we are ready to finish up our QA session. So once we finished our QA, we will go back to our RayCare treatment screen and finish off our patient QA session. So let me see. Yeah, a nice thing here is that we can also update. So that's finishing off the session. Just entering the passwords. And yeah, a nice thing that we can also do is we can update the QA status at this stage as well. So we set the status of the QA to QA passed, and it automatically gets removed from our plans to QA work list. So that's especially handy if you have more extensive QA list to do, in order to keep some track of an overview what measurements you've done and which one you still need to do. Yeah. So that's really handy. Yeah, and all went well. So with our patient physics QAs, we are ready for our final physics approval, where we are again linked to check the same sanity check questionnaire, as I call it. So that's the same list. And that's another MPE buddy, proton buddy of mine checking my plan. So that's really nice. And so we definitely can assume the plan is truly checked, because it's planned by a physicist, checked, and yeah, checked by another one. So there's definitely a lot of people involved in the planning progress. Yeah, and we are ready to approve the treatment course as well. So that's a task linked with final physics approval. And once we approve this, so that's the lock button there, we also allow clinical delivery of our populated treatment sessions, and we lock the RayCare treatment sequence with this step. So prior to this step, the plan was only deliverable in RayTreat QA mode. Now it should also be clinically deliverable as well. And linked with this approved treatment course step is actually the final task. That's also the approval of the setup instructions. And here it's also important to have the correct planning image set. So since this will be the one prompted to our IBA imaging software in order for our RTTs to perform correct matching. And this, of course, needs to match our planning image, of course. So that's all nicely done. And we are ready for our patient to start their first fraction. Yeah, and I want to take you to our treatment session. So here you see all of our screens in our treatment control room. So there's definitely a lot of screens and workstations to be found here on this main wall in our treatment control room. But I want to focus on the 2 RayCare and 2 IBA screens. So that's them. So our RTT work is following on those workstations. So firstly, a patient gets checked in our dedicated RayCare check-in screen or workstation. We then move to the second screen. So that's the RayCare treatment workstation. So that's basically the treatment side of RayCare, and where the patient treatment session is then opened, and automatically with this initial RayCare check-in, the patient's plan is already being sent to the IBA site. So that's Adopt Deliver. Once a patient plan of the day is open on the delivery workstation of IBA, we can also launch an imaging workflow within the IBA software. So that goes back and forth there. And so our first screen is the RayCare treatment agenda, where we check in our patient. So that goes as fun. I have a little video just quickly, check in the patient there. And then we can move to our second screen, which is the treatment side of RayCare. That's the RayCare treatment workstation. And simultaneously in our RayCare agenda, we can have a look at this. We can see the check-in patient progress. So it's basically now, it was black before, that little bubble, it's turned orange. And once it's transferred all of its data, it's turned green, as it's done now. And we can open up that session. So that's really intuitive. And then we open up the treatment session in RayCare, the treatment site, and are again prompted with our setup instructions. I would say, as you can see, that data transfer time for this 4 PT beam set seems very much reasonable to me. And that's partly thanks to our housekeeping or tidying up steps earlier on, where we remove unnecessary planning or optimization RT structs from export. So doing this step definitely shortens this transfer time. Anecdotally, the transfer time is a bit longer, so up to a minute for our CSI patients, where we just have a really bulky RT struct set and a long CT. Same with our ProteusOne esophagus patients. There we see also longer transfer times, since we generally have a lot of beams, so that's 7, 9, even more beams sometimes, and bulky RT structs and such as well. And here we are inside our treatment room. You see our IBA hand pendant, and I have a lovely video there. So our IBA hand pendant, which is basically a smartphone, and we see our Leone robotic 60 of freedom couch moving from the patient loading position all the way to our localization point or ISO center. So this movement is going really smooth, in my opinion, since it's going to this previously calculated and entered couch coordinates. So if the IBA system does not have or does not receive such a setup position coordinates, and our RTT need to manually move to this laser position, I can assure you that movement is not as smooth. So when manually moving our couch, our couch movement is more of a 1 axis per time movement, so really a robotic type of movement. So we definitely gain efficiency here in this step, and we've received good feedback from our RTT team, and that brings me joy. Once we've reached our ISO position, our RTTs are just meant to check for perfect alignment, of course, with our laser markings and our lasers, and they might still need to do small adjustments, since I mentioned the shortcoming of our in silico calculation is a table sag. So that height quite often needs some small adjustments to make a perfect initial setup. And after that, our RTTs are ready to perform our general IGRT, so imaging, and to perform the treatment for all beams. And I would say that first session goes really well for our patient, and so subsequent fraction go really well as well. But one thing we can't forget is we still have our boost plan that we needed to finish off. Of course, we were lacking the final contours at the stage of treatment start, so in order to not lose oversight of this boost planning still needing to happen, a parallel replanning workflow was already added prior to treatment start of that first beam set. Here. Yes. And here you see me doing that. Basically, in the workflow management tab in RayCare, we click on the planning plus button, and you can simply add this replanning workflow. So this parallel workflow consists basically out of the same RayCare components as our initial workflow, going from contouring, planning, MPE, MD checks, all the way to treatment start. Yes. And I've already showed you of our plan in our first beam set. So that's approved beam set, use plan and treatment course, and approve the treatment course. And for the planning of that second beam set, these steps are exactly the same. So we use the same sequence, and yeah, quite luckily didn't have to reinvent the wheel there. So that's nice. So again, beam set approval is done by a random team. Use plan and treatment course is done by the MPE. After some more plan checks have been done, the population of the treatment slots allows us to perform based on specific QA. And since at this stage, the plan is only deliverable in Ray-treat physics mode, we cannot accidentally treat the patients already with this semi-finished beam sets. It's only after successful patient physics QA and some more final MPE checking that we deem the plan fully approved. So the treatment course is then set to approved, allowing us to deliver the plan clinically. I already want to note now that you see a planning of a second beam sequence beam set in parallel to the first beam sets already being under treatment. But I would say the same sequence works just fine for plan adaptation as well. So that's also a possibility where you can use the same sequence. In my feeling, the granularity of the sequence of RayStation approval tasks linked with RayCare tasks gives us safety. And additionally, we kind of keep the same order of tasks as our initial planning. So in a way that gives us efficiency as well, since this one sequence kind of fits most of our scenarios, makes us not having to reinvent the wheel there, and makes us agile for any change of circumstance within our patients. And all is going well, and we're somewhere midway our treatment fractions where when for the purpose of this use case, a major PT machine breakdown happens. So that can happen, of course, that our proton therapy machine breaks down and we can't treat our patients on the proton machine for that day. And luckily, the PT division, so particle, is really embedded within the radiotherapy department of UZ Leuven, and we have 5 Linux lying around. And it's only like a 2-minute walk from the corridor from our PT machine to our Linux for our patients and our staff. And I would say, even though me and some of my MPE colleagues who specialize in proton therapy, we all still very much hang around on the photon side as well. So I would say there's really no barrier for most of our staff. So we have the possibility to treat our proton patients on one of our Linux. And for each proton patient starting on our proton machine, we make sure we have a backup photon plan ready prior to the patient starting on the proton side. So we can really guarantee continuity of treatment for all of our patients. Since the title of this presentation is safety and efficiency, the ideal setup to showcase safety and efficiency would be to have the TPS and OS also in a RaySearch environment as well on the photon side. But however, this is not the case in the photon department. Here we have the TPS and OS of the other major vendor out there. So that backup photon plan is not planned and recorded in the RaySearch environment. So we definitely need to do some manual recording when we deliver a photon fraction on the photon side. So our recording happens for proton patients. Our recording is centralized in RayCare RayStation, of course. And this happens as following. We go to the RayStation treatment delivery tab, where we need to select the correct fraction. So that's linked, of course, linked to the correct beam set. So depending if a WVI or a boost fraction has been delivered on the photon side, we need to manually record that fraction. And we do this basically by manually entering the foreseen MU per proton beam for that fraction. And then our fraction appears fully delivered, manually delivered. Needless to say, this is really a 4 eyes kind of task. So this manual manipulation is essential in us keeping track of the correct amount of delivered dose in our RayCare treatment progress tracking. Yeah, and for me, an extra point of attention is when we override these sessions for patients with several beam sets, such as for sequential beams, as in our WVI example here. In our clinic, quite often this decision is made to deliver the boost as a backup photon option, since the benefit of protons versus photon is generally less present for a smaller boost volume. So if the PT downtime happens early on in the fractions of the patient, we may treat an out-of-order boost session on the photon side. So in that case, we need to be extra careful to select the correct fraction to override. The boost session was delivered, we need to override a boost session in RayCare as well. So I think you also see the danger here when this is done wrongly, of course. Therefore, we really ask our RTTs to buddy up and truly look at they do the correct recording when they perform this modification of delivery. And yeah, good news, our proton machine is fixed again, and the patient can continue the remaining treatment sessions on our proton machine as foreseen, and the patient finishes their treatments. Yeah. And I also want to show you, go over really specific safety and efficiency steps in our workflow, which you've seen now. First off, we ensure clear setup instructions, which are then prompted several times during our RayCare workflow. And that's also prompted prior to every patient treatment, of course. We have our plan tidying up steps, which are very specific to our IBA system in a way, such as making sure we only have one set of beam. We also have our intuitive and automatic beam naming script. And we also have the manual step where we create our beam-specific low dose ROIs, so that's showing the beam entry path for each beam and projecting them on our CommuCT. That if we move to the MPE and ND checking phase, we see efficiency in our usage of our plan checking script. So really happy with that. So we see also both safety and efficiency in the innate granularity of really those RayStation approval steps and its linkage with the RayCare tasks. So that's plan approval, treatment scheduling, of course, and treatment course approval. So I would say this kind of one sequence fits all circumstances, works really well for planning that second beam set in parallel to the first one already being under treatment. That works also really well for plan adaptation. And then at treatment start, yes, we see efficiency because we have our automatic positioning for our first treatment session, since we calculated that position in IBA coordinates with our script earlier on and enter that in RayStation. And to finish off, we can guarantee continuity of patient treatment, whatever happens, even if our proton machine breaks down for the day, since we have our backup Linux available as well, so we can deliver a backup photon plan for that day. So really grateful for that, because if there is ever a machine downtime, we can ensure continuity of our patients. However, yeah, it needs to be recorded extra carefully in our manual recording of that dose in RayStation RayCare. Oh yeah, that's our safety and efficiency steps that you've seen. And to finish off, I'd also like to look at the total picture together. So a little reflection of our past 3-4 years of clinical usage and some possibilities on what the future might bring us. So I would say, first of all, our multidisciplinary approach, where we try to find gains within all of our disciplines. So that's RTTs, quality managers, MPEs, and radoncs. That just works really well for us. So within all disciplines, we try to look for small or maybe larger gains and try to incorporate that into our workflow. And that's, in my feeling, really what happened over the years and versions. We keep finding little things where we can improve our workflow. So our workflow workflows transition, evolve, and became more modular. So in a way, we started with a more simple, more generalized workflows and evolved where we are today with more frills and more modularity. Much like in the Pokemon gotta catch 'em all world. So we started off with a younger product in terms of RayCare workflows and maturity. And as a center, we were also not an experienced user as we are now. So both in maturity and evolving on the RayCare side and on our side, or we moved towards a more advanced state where we are now. So we really started off inexperienced with our first version, where there was more one general all-encompassing, really long workflows with no frills, so that mentality. And in reality, we did have more than one workflow. Of course, we had deviations between anesthesia, non-anesthesia, pediatric, non-pediatric. We also had a dedicated CSI workflow, some dedicated intracranial workflows. And or one frill back in the day was the QA workflow, which was basically a shortened version of the really long RayCare workflow. So mostly back in the day, our workflows were really long and all encompassing, whereas in the newer RayCare versions, we see more workflow frills, and we also see the move towards a more modular approach. So, and more modular permutations allow for basically an exponential amount of options in order for us to handle nearly every change of circumstance, such as plan adaptations, planning in parallel, an in-room CT calculation, replanning, new simulation, and much more. So we definitely see a more advanced product in a way. That's my feeling. So we really went from Charmeleon to Charizard in a way. Yeah, and here you see the possibility, for example, to add a new module within a current case workflow with every plus symbol, basically. And maybe a little frill example, in my opinion, is the possibility to add a direct order, such as here you see the top, you see the in-room CT workflow order. So that's a direct order. Yeah. And a next point, which I also raised earlier in this presentation, is that we're nearing our most wonderful time of the year again. So it's coming up end of this month. It's time for our yearly RaySearch version upgrade. And maybe to stay in the Pokemon team, it seems like we're catching every upgrade, so gotta catch them all. We basically had a yearly RayCare RayStation upgrades, and these upgrades provide us with a high MPE workload to prepare this correctly. So yeah, that's a lot of work, but with each upgrade we end up with the most new package, and we've seen improvements, of course, throughout those packages. So for example, the granularity of the RayStation approval tasks and its linking to the RayCare workflow just feels much better now compared to the version before. That's my feeling. I'm also looking forward to having the LED evaluation in our newest RayStation version. That's going to be out in a couple of weeks for us. And yeah, as a last thing, we also see a large increase in both the RayCare Proton community and more specifically the RayCare IBA P1 community that will expand vastly in the coming years. I'm looking at our soon-to-be Spanish friends, I guess, where 10 P1 centers will go clinical in the coming years with the IBA RaySearch package. So I'm sure, yeah, a larger community with our exact same setup will bring us gains, since I'm sure that it will improve each other. So I'm really looking forward to that in a way. This is, of course, our team at UZ Leuven particle. And yeah, I think we can move on to our Q&A. Seems like we went okay on time.
Yeah, thanks a lot, Ellen, for a great...
Oh, no, I closed down the... Wait, no. Let me go back.
That's all right.
I think it should be back.
Yeah. So just a reminder to participants that if you have any questions, then you can enter them in the question and answers box from your side. There is a few that have come in, so we can start by trying to answer those. So the first question is, you talked about a lot about safety and efficiency. The question is, which part of the workflow, for example, simulation, planning, or treatment, do you see the most efficiency gains from since you started using RayCare?
Oh, yeah. That's a good question. Thank you. Yeah, for me personally, yeah, for example, simulation goes quite smooth as the main planning image is already loaded and opened in the RayStation while the patient is on the CT couch. So another area where we see efficiency gain is in the planning phase sequence, where the task passes on smoothly between the user groups. So that's the planning MPE, RADONC, and then the checking MPE. And of course, that automatic transfer to the treatment site, because we're working in one software environment. Yeah, that's basically the largest integration advantage. So, and also that automatic availability for both patient QA delivery and patient treatment makes just that workflow really smooth. I would say, yeah, if you ask me where for me the biggest efficiency gain is, it's really plan adaptation, because that's a moment, yeah, which is really time critical in a way. So having that automation and passing through the user groups there, being in one environment, for me personally, that feels where you have the biggest efficiency gain, if that answers your question correctly.
Yeah. You said the next question is around community. You said you're looking forward to more users with similar profiles. Do you collaborate in any way with other RayCare users or a user community?
Yeah, yeah. I must admit, I'm personally not very active on the RayCare forum, in the RaySearch community. I know on the RayStation side, there's lots of questions being asked there on that forum. So personally, I don't do that, mea culpa. But for me personally, the user meetings are really a good way to connect with one another. And maybe, yeah, these sessions are also a good way to connect in a way. I would also say most centers that are starting with RayCare and IBA or RayCare Protons already got in contact with us, either via a personal visit or a Teams introduction. So yeah, we do have currently that personal connection with most other RayCare Proton centers. So that's something I really enjoy. And at the moment, yeah, any RayCare issues that arise within the community where we want to have like some feedback from another center, that's handled yeah, basically through direct communication. So either via Teams call, quick email, we even have a WhatsApp group with Italy. So yeah, I do personally enjoy that.
The next question is around partial treatment. So how convenient are the partials handled by RayCare?
Yeah, partial treatment, we do have that quite often, since it, yeah, can happen for a variety of reasons, either IBA glitch up or machine, yeah, not full breakdown, but some resetting that needs to happen, or yeah, a patient that's unwell that needs to be taken off the table. So we do have that quite commonly, and yeah, it's basically just closing down the session. Then yeah, when closing down RayCare on the treatment side, it automatically asks, do you want a continuation session? We keep that ticked, of course, and then we can reschedule that continuation session. So yeah, in my opinion, that goes quite smooth. The only downside is if it hasn't happened in a while, then I always need to think, okay, how do I need to schedule it? But that's yeah, generally that goes quite smooth.
I will take the next question. So this is, for varying machines in your clinic, do you use ARIA? If yes, do you transfer any information from ARIA to RayCare? And I can tell you that for the TrueBeam family, the interface for those machines will be released in the coming version. And we have several ways if the clinic wants to use RayCare in a coexistence scenario. In other words, if they would, for some reason, want to keep their existing ARIA up and running, there are several ways to communicate information. And I think we can reach out to you and give you the details around that. But either you can choose to completely move over to RayCare, or you can indeed have coexistence. In other words, you can have both RayCare and ARIA running and send information between the two. That was that question. We'll see how many more we have time for, but how much downtime have you had caused by RayCare since you went live?
Oh, yeah, I would say our RaySearch software environment is generally stable. So I would say nearly perfect uptime in terms of stability. Yeah, maybe something worth to note is that we also perform our morning QA through RayCare. So there's so if there's a service restart needed or like a specific Citrix issue, for example, it will get picked up early on in the morning, and that sporadic server restart, for example, will already be performed prior to the first patient arriving. So yeah, pro tip, definitely include RayCare as part of your morning QA. We did have a couple of issues with individual patients, so where the link between the RayCare patient and the RayStation plan was lost due to a chain of basically data addition within the patient flags and some subsequent synchronization issues. Quite luckily, the most severe, the severe patient where this irreversibly arose was our morning QA patient. So we're lucky on that side, I would say. And actually, this specific broken patient issue should be fixed when we upgrade as well. So yeah, also worth to note that when this happens, we just log a case on the RayStation side and get the needed support and further investigation from RaySearch, as you would expect. So yeah, really, in order to keep your downtime down, my advice would really be to include a RayCare part as part of your morning QA. Really, that's helped us a lot, especially for downtime. And apart from that, it also helps having that as part of the morning QA to force basically the whole team to work with RayCare on a daily basis, because you can know a product better if you use it on a daily basis. So by putting that in the morning QA, yeah, we've expanded our knowledge as a team in RayCare. I don't know if that answers your question sufficiently.
I think that was a good answer. I think we'll try and wrap up so that people have got time to get back to the clinic. So we've got a few more questions here, and we will do our best to try and reach out to those people individually. But I would just like to thank you all again for your participation today. And another reminder, next week we'll hear from Dustin Simonson from Frederick Health Radiation Medicine in the United States, and he will talk about RayCare, the RayCare implementation on their CyberKnife. So we hope to see you all there. Thanks again, and enjoy the rest of your day.